I see it's red. Okay, so hi everybody. So what is the idea of the workshop today? I just I did last year a workshop about the basics of compositing, and which was kind of like I would call a boring workshop when you're talking about stuff that everybody's supposed to know, and everybody apparently don't know, or most of the people just saying, well, that's not important. But I try just to put the very basic stuff like A over B as a base of successful compositing on a technical level inside of how you're building your script, how you're looking on your footage, and so on and so on. So, and then I was thinking that it will be good to have the same idea of workshop about basically what's happening before you're touching your actually your tools. So why you actually want to bring certain layers, why you want to bring certain color correction, how you want to, why you want to approach shot in specific way. Because when you're already inside of Nuke, that's it, like you go, go, go. You need to technically be right, but in many cases, in huge amount of cases, there's many comps with when people kind of technically right, but things just do not look right, and even if it is right, it's actually wrong because of specific technical or artistic points that they did not pay attention to. So very much from beginning, I want to kind of like this kind of step back. It's a knowledge that I did kind of collect for myself. It's my experience in the way how I think. So this is not something that everybody is supposed to take for granted. Kind of like, okay, that's the right thing what he's saying. That's my experience. I'm missing many things. I definitely not rocket scientist. So I have certain understanding of stuff. I'm using them, and just in this workshop, I just wanted to. So I said at home, and I was thinking, well, what actually are things that I'm kind of like that sending you to do specific decision, and then like, well, and then you're going just backwards, like exactly as you're walking, you don't think about why you can walk actually or run. You're just like, well, I can do it. But behind that, there's some very, very basic things that you never thinking about. So I was just sitting and I was like, okay, let's think about things that are in the basics. And then I just threw everything inside of this Google Sheets, and there is not very much a lot of order in there, but at least I try to separate a few things that I would like to talk about. Okay, so I think that's enough of introduction. Let's just have a look on the summary and the first things that I kind of like, okay, how can I split everything? We're talking about the pictures and how pictures are created. Somebody is thinking about, he has an idea, for example, the director has an idea, I have a dialogue. Well, sweet. How are we going to shoot this dialogue? Then he's sitting with the cameraman usually and the art designer, and they're starting to talk about, okay, what will be basically the idea. I'm talking about films, by the way, here. Like, we're not just talking about like, oh, I don't know, something, we can't talk design. You know, we're talking about how movies are made, and this is not a secret. The director is sitting, the director has an idea, and then people do have generally visual idea how it's supposed to look and feel, and then we're going, after we already have quite big amount of stuff, how we want it generally all movie will look like, we're going inside of the shots, and we're starting to split even more and go inside a specific picture, how does it look like. And here we are in a picture, and the picture, if I will look on this, there will be a few basic things that I would like to kind of like to judge, is the color balance, the geometrical balance, and actually two, because perspective laws is just, I did add something that we need to kind of always pay attention, or at least for me it's very important, or how I'm reading the picture. Okay, so first thing, let's talk about color palette, and why is this supposed to be decided in very, very beginning, and how it is done. I just found a very nice site with which just collected color palettes from different movies, and it's very nice to have it here in the lower part, because you kind of, you're not looking on the picture, and you can just see, okay, that was the color palette, and actually if you, I will now go through this, each one will give you specific feeling, so each color has meaning. And important thing, everything that I'm going to talk about today, everything, it's Western art. So it's based on Western art and Western civilization in general, and it's connected to art, it's connected to the way we see the life, the way how we listen to music, and how we write, and you will see it in the very soon, okay? And for every culture, colors are defined differently. So for us, I don't know, orange will be danger, and blue and will be calmness. So there is like huge research about this, and it's not about what artist is deciding. No, it's all kind of like was done in psychology, in study of psychology, and we're basing, that's our kind of like stones on which we are basing our decision, like our brain just, oh, it's dangerous. And it's coming in way more from inside. So director will choose the color palette, and this is one of the first things that and I'm kind of like, will try to jump to what we're actually doing there. Okay, when we're trying to support the picture, we're trying to create the picture, we always need to think about what was the idea. Do we want to create a movie which is like dangerous, or like what was the actually idea of the director? I will jump here between few movies, which so you will kind of be able to connect your memories. For example, when you remember this movie, like that's fair enough, right? You don't remember something else, and like something else when I was saying, okay, what will be, well, let's leave this one for a second. Also, it's also quite kind of, we can relate to these colors, but then I think next one was really, I was like, oh really, that's it. And like the accent that they're doing with the red, which is just, you know, jumping there out of everything, it's how it's already, how the director of photography is playing with the colors and with the light. We'll touch it in the kind of like a little bit later a lot. This is very dramatic change from previous movie, and that was not decided on set, that was not decided while they're shooting or when they're editing or color grading. Of course it was supported, but that's important, the choose of textures in our case, but the choose of clothes. Art department was sitting and was saying, no, he has to wear this, he has to wear that. It's something that I did science cinematography, and many times we kind of like, as students, okay, and then we'll grade movie in a certain way. No. Before you're shooting the movie, you're sitting with art department person and just like, okay, you will wear this color, this color, this color. We will see this in the many examples. So your movie is supposed to be, your picture is supposed to be color balanced. And as you notice, I'm not talking about like, dude, this saturation is too much because you're out of gamut. That's the usual thing that we kind of like hear in compositing. No, I'm talking about your gamut is fine, but this color just not supposed to be there. Okay, I will jump back to my summary, and then let's talk for a second about color balance. We will go today through many photos that I collected, and then we can start to just think, like, after we will have this very dry introduction, we'll try to see, is it there, or maybe like this is bullshit. Of course there will be a lot of bullshit because I'm just deciding that it's there. But let's say have a look a little bit more. Okay, geometrical balance. So let's say we have a color balance, we understood where we want to go, how we want to see it. Geometrical balance, general thing, people, we do like see balanced pictures. We feel very comfortable when we see balanced world, which means we are 90 degrees, right? Eyes are here, try to do like that, something is fishy, right? And it's really fishy, you're not used to it, just don't do it now. But generally, we like to have a balance. Now, how our pictures are created, and now you can remember every like classical works, because cinematography is really heavily based on the classical paintings. Okay, and we took from there like everything approximately. What will be geometrical balance? There's two types of balance. Let's say there is a formal balance and informal balance. What is the formal balance? Is when you have a person in the middle of your frame, you have an object in the middle of your frame, everything just straightforward. You have on the left 5 meters, on the right 5 meters. He has slight space above his head, and this is balanced picture on the left and on the right. This is formal balance, but most of the pictures they are not like that, and then formal balance is also pretty boring. What will be informal balance? And I will talk about this a little bit. And then we will see all this, and you actually can tell me. So informal balance, it's when your picture is slightly unbalanced, but then there is second element with the balancing the picture on the other side of the frame. Okay, so and how does it work? For example, you can put a very big object on the left side of the picture, and it will be like, and there's like, I'm coming now how we're actually using it. This object will be just a black bulb, whatever, black something, like defocus. And on the right side of the picture, you can put very little object, which will be very, very bright. And this little bright object will balance the picture back, because bright, sharp source can balance the big one, which is black, without the features. Now we're going to feature the same with the sharpness. If you put some object which is very sharp on the one side and another one, even bigger one, is and blurry on the other side, you will be able to balance this picture. It's used a lot. It's also helping us to even to take all our attention, because we like to see sharp stuff. That's why kind of like, in every movie you want to see what is in focus. We're used to that as a human beings. We will go there. Another way, it's so basically that was what I'm missing there. There's additional one, and this one, and well, colors. The same with the, as I was mentioning, with the brightness, you can also take very desaturated colors on one side and very saturated colors on the other side, and you will have a more balanced frame than if you would just leave all colors the same. I deliberately talking now in the air quite a lot, because I would like to give you this dry thing which maybe makes no sense, or just like, well, of course I know it, but no worries, we'll just go there and then we'll start. 1, 2, 3, have a look on that. Okay? So this is general kind of like, this is a geometrical balance. Let's talk about additional stuff that actually I didn't remember. But we, of course, we did study this in, well, kind of like in the cinematography, and I think everybody who did, I think it will be good refreshment. So it's called Gestalt Laws, written there. And it's actually something which is coming as well from psychology. And why is this important? Because this is actually affects how we see stuff, or it's just representing our very basic stuff of how human beings are perceiving the world. Okay, so for example, law of similarity. If you have these red dots and blue dots, we'll see two groups basically, and we very easily taking these two groups and saying, well, this is one guy, this is another one's. Law of pregnance of the law of good figure. Okay, so it took me like kind of like some time to go what they meant, but basically we don't like to go to details inside of very detailed big figure. What we're doing, we're recognizing the contour, we're recognizing the object, and we're saying, we kind of like, fuck it, it's all not interesting. We're getting general picture, and basing on our life experience, we're giving you an answer, because we don't want, our brain doesn't want to work very hard. It's just, oh, it's human, and this is a deer. Okay, we're using this tremendously, we're using this a lot, and it's very important to use this one, especially, not very important, that's something that also young cinematographers like, it's just over-lighting, putting tons of light in the front of the person, just like this is the guy. Well, you can put very little light behind the person, then you see, oh, this is silhouette, this is a guy, this is very dangerous because we don't see his face, blah, 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 blah. I will give you an example of this guy, for example, which was quite cool. So, so we have this kind of like line, okay, of course, and if I will be able to move this slide inside, it will be just great. I love it. I will just move it here, and it will be updated. Am I right? Bam. Okay, cool. So now we see that it's actually not lined. There's like, if you will see this picture first, you will see that there's like some hamster. That like we have very bad light here, but generally it was so. And that's the relation. So you see the main picture. You kind of like, you're not going to details. You're not starting to look something. That's like, well, that's the line, and actually it's extremely well visible when it's without this. Actually, can we reduce slightly the light, just a little bit? Yeah, sweet. Okay, cool. So that's quite good example that we losing the very details which are inside. We're getting just general information, and we are ready to go. It is extremely important especially for compositors, because many times we need just. Let's add something on the background, we need something there, and then we're overdoing this. Instead of just like adding very few lines and say this is a forest, because people like, there's lines in the background, probably it's forest. They're starting with the and it's not necessary, and it's done amazingly in the paintings. If you just look for it, you will find it. Okay, cool, let's, next, proximity, easy peasy, okay. These guys are closer to each other, which means this is two groups. Law of continuity. We can see this as a line. It's actually dots in the space. We as humans see this as a line. tremendous amount of time we have some kind of like actor is wearing something like this, and then behind him there is a, like we're putting some background, and then there will be a line under the background, the corner, and then the director will go, no, 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 let's move the background because it looks like he's part of the background actually. And that is happening many, many, many times when you just put two lines together and you're just like, oh, well, it's already not working because you're perceiving this and you're kind of like, what's wrong with perspective, what's wrong with depth, and so on and so on. Law of closure. Also, extremely important thing that like used a lot is the same. So we try to make sense out of this shape. So we don't see it actually as a three broken lines. We see it as a, how do you call this shape? That's right. Yes, I don't know in English, I'm sorry. So we see it as a one shape because we do close this by ourselves. Okay, and it's happening like all the time. I didn't actually. I think I can show this as a little example on the picture on the left side. For example, you're building the picture of the human from very little information. So, for example, because you know human face, you know that there is a face, there will be eye on the other side, and here you know that this is actually his neck and not something that is somewhere in like you know in other world or something like that. Okay, let's see. And so I find these guys, this guy, and this guy, they're really appearing in every frame. You can see it everywhere. And the law of common region is we definitely know that these two dots are not related, but this dot and this dot are related. Why? Because we close them. When I'm looking at you, I know that this is like one row, this is the second row, and Julius is completely out of the business because he's somewhere there, so he's not related. And it's very simple, very natural. So it's a line which is connecting these guys, a line which is connecting these guys. Hello, sir. Okay, so so this is like very dry laws. We will go through them again, and this is in very, very base of us. We know this. It's not something that you need to be very artistical to know. No, that's how we work as human beings. Okay, cool. So let's see where I was and where I want to go right now. So now, regarding now I will stay still with some kind of geometry perspective laws and why they're important, and like the one thing that I would share like geometrically. I'm terrible in painting and everything which is connected to that, but this will be the most important like perspective law that I'm using this. I'm using from the moment you know this, you're using this a lot. So so each object will have like each frame will have a vanishing point, 1, 2, sometimes 3, sometimes 50, but usually let's talk about 1 as a beginning. So here if you see there's another one, because this object is not rotated there. But we're dealing like a lot with pictures like that, for example. Okay, and many times you need to scale one object and put it more far away. Okay, so the usual thing that like people can just say, well, I will cut this guy, I will put transform, I will put here, I will scale it, looks good. No, it's like reasonable, but it will be wrong. Okay, so you can easily do that, and just you need to use the law of perspective. That's all like lines going to meet in one point, all parallel lines going to meet in one point on horizon, and it's called vanishing point. And you see this guy, this is vanishing point of these objects. Okay, so that will be 1, which means if you want to scale one of them, you need to take pivot of your transform, bring it to vanishing point, and then you will scale it. It will properly stand on the ground, it will have proper height all the way. Okay? Many times, like a really tremendous amount of times, we need to replace something on the ground. For example, here. To place properly this guy there without this law, you just can't. You will need to bring corner pin, you will need to have how it looks here. No, you're just taking this guy, cutting this out, pivot far away, scaling it in. Sorry, I'm going a little bit technical here, but the general information how actually the vanishing point works. If you want to put them in the same distance, 1, 2, 3, 4, how will you know how to do that? And it's also quite simple. You need to have at least 2 to start with, because you don't know what is the distance. But if you need to put more of them, you need to put line from the bottom of the first one through the middle of the second one. I'll just give you a second. I'll put here. Sorry. So basically, you have only 2 of these guys. Then you're taking this and you're saying, or even you have 1. So you first of all you're going to make this line in your with rotopaint, whatever, like there's little tools to help. And then you're going this, with the top to your vanishing point. So it will be this height, but how far away? Then let's say you made first guy here, and then where will be the second? So you're going from the bottom to the middle of this guy, and where you will meet this line, that will be the same distance in meters from here as from here. And that's very simple. Okay, it's very basic kind of like thing, and it can help you to make your stuff in the, like in the proper way, and you will know 100%. No, I know that this, and like humans, you need to multiply a few guys which are walking. That's what you're gonna do. If you want to put somebody a little bit more far away, that will be like that will just work. Okay. Of course, you need to stabilize your stuff. So if you have moving camera, we can make workshop about how actually we're doing this technically. Because if you have moving camera, your vanishing point going to change because it's moving in the space. I mean, it will be the same point in 3D space, but in screen space it's going to move. But this is different. Let's keep running. Okay. So that was general talk about the perspective laws, and now I think we can jump to the next thing, which will be important. I cannot jump here. Let's keep up there. Okay, so sorry. So it's what's happening in the scene. Okay, so we're basically dealing with everything that camera can record, and I will go through things that's happening from very beginning to the in the scene to the very end, which is a sensor. I will say sensor is the end. We will not talk about the rest. Okay, so let's talk about the actually very few things. It's light, which is everything basically. Then materials, atmospherics, and then we'll talk about some color correction things that I would kind of like to emphasize. Okay, so let's talk about the light quality as very beginning, and it's very base. So everything what we see is a light, like everything. There's nothing that we can see otherwise. Okay, it's light which is going straight to my eyes, light which is emitted by projector, and the rest is the light which is reflected from everybody and everything else. Light has few basic qualities that I will kind of emphasize. It's light temperature and softness and fall off. I will kind of like, as you spread can go away because it's also will be kind of like the all derivative from each other and stuff. Okay, so let's talk about the first basic thing is light temperature. Okay, light temperature. So light temperature is we kind of like using this in kelvins, and we like just a general very basic thing that everything which is inside of the house till now, till like 2000 of course, because then we have different lights. It was always, it's called tungsten, and temperature of light was 3200 or lower, but basically actually it's a little bit lower because 3200 is the temperature of standard light on the set. Like you have ARRI lights, so standard one which are tungsten. Tungsten is just you have daylight and tungsten. Tungsten is the warm light, daylight is the cold light, and here we go, warm light, cold light. The warm light is used to light environments inside of the house, because usually we're going to be approximately this temperature. Our bulbs, old bulbs, are even lower. They're like, let's say it's somewhere here, and tungsten will sit here. And then the temperature 5600, it's approximately here. This is the daylight, considerably daylight, and this is just sunlight. When we have more sky, more clouds, and we have more atmospherics, our light getting colder and colder and colder, and we go into the cold palette. So this is very basic thing about the quality of the light as a temperature, and this is actual temperature, meaning if your fire is getting hotter and hotter and hotter, your temperature is rising, you're getting colder and colder and colder, and then if you have less embers, they're very orange because their temperature is very low. So that's like part of the communication. We want to be a little bit warmer, we want it to be a little bit colder. It's a little bit actually the opposite, and that's causing confusion because I just was saying that it's very hot temperature wise, but we're saying that it's getting colder because the look wise it's just colder. Okay, so that's a little thing that can confuse a little bit, but I assume that that will be the base of thing that you want to know. Then next thing is it's the most, I guess, important thing is the light fall-off law. So light falling off, which means dissipating, not in linear way, it's dissipating, it's called inverse square root law, I guess, right?
Yeah.
Thank you, because I have lighter there, now I'm light. Okay, cool. So, and that's great picture just to show you how does it work and why we do care about how it's going away. Okay, it does work like that. In the first meter, you will have this amount of light. So you have 1 square, okay, filled in. Then you will double this, and when you will double this, you will have only, in which square like that, you will have only quarter of intensity of this guy. So you're doubling the distance, and you have quarter of the previous one. Why? You can see. Okay, when light is emitted from one point, which is in most of the cases, that's the case, and in nature, definitely. And then you're losing always 3/4 every time. So twice bigger, quarter light. Twice bigger, because we're now comparing. And we're getting the quarter of the light that was there. Okay, so this is exponential. Here we'll lose the most of the light, but here the twice bigger the distance is way, way, way greater. The best example is the sunlight. Sunlight has no fall off at all. Why? Because we're so far away from the sun that this distance is so great that it doesn't matter if you're standing like on one side of the earth and then on another side of the earth, relatively to the sun, you're so freaking far away that there will be zero fall off. Okay, I'm not talking now about atmospherics, okay? So atmospherics, they also will give you some spread of light. We'll talk about this in the atmospheric place. But this is extremely, extremely important idea to understand and why. So let's go now to why. If you want to create feeling of the daylight, or if you want to create feeling that there is a sun, you always need to think about this. Okay, there will be no fall off. Many times from the set, we're getting something with a shot, and then people saying this is the sun, but you're saying it looks like studio. Why? Because you're looking, and you don't know why actually. You're just looking at this and like, well, I have no idea, but it looks like studio. But then when you see the one guy is here is lit very, very strongly, the next guy there is lit a little bit less, that's it. Your brain just like, no. It doesn't work with the sun this way, you can't do it. Okay, so this is, because this law is kind of like kicking in your brain, you're just like, well, that's the thing, okay? As well, what it gives you, additional thing, if your object is very, very far away, but you have very, very little spread. So this kind of like thing is going to be less and less, so light is more and more direct. So when you have sunlight, the light will be way, way, way more direct than if you will be closer to the sun. But here we're coming to something else. We're talking about the spread and how light is spread. So basically spread is of the light is how soft your shadows are going to be, and this is dependent on the size of the emitter. Okay, if emitter is very big, you're going to get soft shadows. If emitter is very little, you're going to have very hard shadows. Something that I did, it always reminds me something that conversation I had with the lighter in this case, when on set they did lit person with a big light, 5 meters away from here, and then we had to replace the area where the light was with a window which is glowing. Okay, so huge glowing window, and lighter did match what was on set, and was kind of like telling me, but that was on set. Person are getting from very little light, which is on set, very strong shadows, but because there's supposed to be a huge window behind the guy, he's supposed to get the soft shadows and not the very hard shadows, because the object that emits, it's very, very big. Okay, how can I paint it actually? Because there's very simple understanding of that. But sorry, I didn't prepare this, but it's kind of like important. So let's say this guy will be our object. Ignore everything else. Sorry, that's like improvisation. Okay, this guy will be an object, and that will be my sun. Okay, that will be my kind of my object that emitting the light. Okay, on this guy. So how we will define how soft actually the shadow is supposed to be? And it's very simple. You're just taking the most far away part of this emitter and drawing the line here. And you're taking the most far away part of this emitter, and you're drawing the same dot light here. What you're getting this triangle, right? In this triangle, that's your softness. Make sense?
Yeah.
Somebody didn't get the point? Now, if you will get the little emitter on very far away, which means smaller, okay, if we'll go far away and we'll do the same line, my soft area will be way, way smaller. You're making this closer, it will be bigger. Okay, that's why sun is giving you so sharp shadows. And we will arrive to atmospherics soon. Okay, so I guess that was it with the light quality. So follow, extremely important. Temperature and softness, it's two additional things. This was basically very technical things. We'll arrive to the pictures to talk about the additional stuff. Okay, so now let's talk as well in technical way materials. So now we know light. Okay, great. Light is arriving. Light is actually invisible as long as light is not hitting anything else. Well, you don't know that it actually exists. It will be just darkness. Have a look on the picture from the space. I guess it's real. It's dark. Okay. So so materials, that will be very, very important part of your picture, and the main qualities of the materials will be, actually we are already here. It will be how, I will just read what I wrote and then I will try to find it. So how soft is material, how smooth is material, how rough maybe it is, it's reflective or it absorbs all lighting, or maybe it's even refractive, okay? And so I just found this picture and I actually didn't read it, but fine. I found this picture on the internet. We'll just explain to you just basic thing of material. So each material is reacting on the light differently. And some materials are will absorb a lot of light. So this is a special material, it's called maltone. This is black, and it's not just black, it has so much little details that light is just like really absorbed a lot, and he's not emitting anything else. In this, I mean, of course it emits a little bit, but way less than this white wall, which is actually absorbing zero and reflecting everything back. Now this light wall, if you put mirror, there will be very different picture, right? A white wall will just reflect all the light, but it will scatter it tremendously, which means you're not getting the specular reflection. You're getting diffuse reflection. Now, big difference between specular reflection, diffuse reflection. Diffuse reflection usually will give you a lot of color. Specular, it will give you mostly the color of the emitter. Okay, and everything that we see, at least that's how I kind of like learned this. It's diffuse reflections, and as roughness is going down, they're getting more and more and more specular, and then you're getting the specks or reflections that you call it in your CG. So everything depending on the quality of the object. Object, of course, they can be different, have few different kind of qualities inside. So not everything is super simple, like this chair or this guy. So there's objects with the different codes that we can create or do exist there. The objects are doing very crazy stuff for the light, and that's something that we compositors are not dealing with, kind of in very base. That's that lighters are dealing. So if they're creating a shadow, they're going to crazy stuff. What is the amount of diffuse level there? What the amount of specularity? What is the amount of reflectivity? Whatever. There's many things that I have no idea in them. What I do have a kind of understanding, I know what we're dealing with as compositors. By the end of the day, we're getting the final baked picture. And that's what I'm going to talk about today. That's what I'm doing now. We're getting a frame. And this frame already did register the reaction of materials. So that's the only shader that we have, that's the only information that we have. So we know that when we're looking at a specific picture, we know that this part of my body is reflecting this amount of the red light, and it's absorbing all blue light, and this part of my body is just generally just absorbing all the light. Which means it's hard for us to change the quality of the shader. It's hard / impossible properly do that, but what is very easy for us, and it's easy for us to alter the amount of light that came there. Because we do have very important information. We have a ratio of reaction of this guy and this guy, which means he already reacted 50 times stronger in the light than my t-shirt, and meaning if I just multiply the same values, I will not change, I will not alter the material, but I will say this material actually receiving now 50 times more light. Okay, and that's why using multiply when we're dealing with the color correction as the first thing. That's your thing. That's the white point. You're just saying we want the scene brighter. You're not changing, by changing multiplication, you're not changing the quality of your materials. You're not changing the quality of your light. Your light not getting stronger and it's getting stronger, it's not getting sharper, for example, when going up. No, just everything is going brighter, you're multiplying, and you're just saying, well, this guy will be multiplied by my grade note, and then he will say probably black, because he will say, well, I'm only 0.05, so I will be 0.1. But this guy will go to 50,000 and will say, well, that's very bright. Okay, this is a very important concept. If we're going to different, if you're going to use different color correction, we're going to just gain it, gamma it up. Okay, here we're starting to get into problems, or it's not exactly problems, but we're changing the light in the scene, or we're changing the material in the scene. Because when we're saying that this guy actually not going to react, but then this guy here going to be way brighter because it's our mid-tones, then we're saying, well, this probably jeans are made from different material, and or your light was not as concentrated as in the beginning, but it's more soft now because you have some bounce there. Okay, so it is a kind of important concept, and plus it's completely wrong. You shouldn't do that, which means offsets. It's something which is, we're saying, let's rise the offsets of the scene. Then we're not saying that we're making the scene lighter, because what does it mean make scene lighter? Amount of light multiplied by actually reflection called reflection index or whatever, by material. But when you're saying let's just plus everything to make everything brighter, nobody going to do, but somehow people do it still now, and we'll arrive to these examples, is wrong. Okay, you cannot just bring like to offset all values and expect that it will work, because it will not. Okay, so that was the scene and materials. Okay, let's talk about atmospherics. And that's something that kind of like got as well, very important thing of the scene, and I promise we will now start to put stuff together before you will fall asleep. Good, atmospherics. So atmospherics, it's object in the scene. Okay, atmospherics is not something weird thing, we don't know what is this, we're not plusing atmospherics, it's objects, we're overing them. I know that we're going to plus sometimes stuff, but what you need to be just very, very, very clear, you have a camera, you have your objects that we know, and this is an object, this is like piece of wood, this is this. In between camera and this object, there will be additional objects. We're not living in a vacuum. This object is going to affect your comp or your pictures tremendously. And that's something that we need to understand when we're looking on the picture, which we will. You need to understand what you see there. Are you see there lens flare, or you see there objects in the air? What is this haze? Is this lens was fucked up, or you have objects which are glowing in there? So what can we have? We can have fog, we can have rain, we can have snow, and of course we can have UV contamination, which is kind of like, for people it's fine, for camera it's not exactly fine, so you're getting blue haze if you don't have UV filter with very far away. And of course we can have clouds. Okay, so let's just step one by one, because each one has a little bit stuff that are important. So first of all, fog. Okay, fog is not just constant with the depths. No, fog is the water in the air. There are waves. There are just fog which is collecting certain shapes. The cloud, which is, because you're so close to this cloud, you actually don't see each object, but it has complexity. Fog is denser in one places and it's less dense in another place. So when we actually want to create fog, when you're getting like, let's make it a little bit foggy, please don't put constant and make it just plus. First of all, you cannot plus it because it's kind of like not nice. Actually, you can plus it, but then you have to break it. Okay, I always will over it, because I'm just like trying to be, okay, this is object, I will over it. Okay, then your second thing, always when you have some fog to add some noise, add some footage, and very transparent, very average to each one. You remember our brain is creating picture from very, very little thing that will just a second, what was it? But it was interesting. Okay, if you put the flat thing, we going to the like 80s when we had lighting without anything, without some sort of scattering, without fall off, and that's what you created. You like in nature, you always, and this is general thing, there always will be a ramp. There's very rarely you will have constant. This constant always, mostly will have a ramp, and this will define how believable the picture is. So we're talking about fog. you want to add some fog, even very, very far away, add some details there. Don't go crazy because the supervisor will tell you, no, that's too much details, but add it because it will add 1% to make your picture more believable. Put it all together, you will be fine. Rain. Rain, very important, different from fog. Rain is water which is already kind of like condensed together and it's falling down, which means we have little drops, okay? These drops will be almost invisible when you don't have light sources, okay? Now, remember rain in your head. You will see rain in the night when you will go outside. Shit, is the rain? Where are you going to watch? On the light sources. You're going to watch on the light source and then you see, oh, drops are reflected. That's how you're doing rain also in comb. That's how you make it real. In the middle of the night, you're not going to see rain. You're going to see rain only if it's backlit, not when it's front lit. And I'm telling from personal experience that was amazing. We were very on set and we say, well, let's make rain. We have rain machine. We put like 2 HMIs from the camera. And they're like, what the fuck? Where's the rain? And there was no rain. And then we just put them back behind, which we're students, you know what to do. And then it's just bam, and they're like, oh, let's dial it down because it's crazy. Rain, we will see through refraction how the water is refracting the object together with how you light in the water actually. If you light from the camera, well, you will not see. If there will be something in water, you actually will see the objects. But if you want to see some reflection and stuff, you will put it behind. So that was the rain. Rain is an object, but what he's showing you, he was showing you actually the colors of the emitter of the light. That's also something important. If fog, for example, and now we're going to fog is a cloud. Fog can be white, fog can be dark. So dark clouds, when they're collecting enough rain, but it's still not a rain, they're starting to get their own color. They're just starting to be a bit darker and bluer. Very soft fog will be white. Now water generally will not have a color, but when it's refracting, what you see the emitter. Okay, also something that you need to pay attention that if you have moon there or whatever, your drop's supposed to correspond to this color, otherwise you will collapse. Okay, let's keep going. So we have atmospheric rain, snow. Snow, the easiest one actually, I needed to start from this one because snow, it's really big geometrical objects in the air which has very good, very big roughness. They have very strong reflectivity, but it's very rough. So you have them as a white. But truly never class snow. This really will be very, very bad because this is just white, pieces of white stuff in the air, which means they will be very white if they will be in front of the dark background. But if there will be very bright background behind them, they will be black. They will be dark. And that's something that gives you, wow, this is cool, this is real. And there's something, sometimes you just put your snow, you class it over, and you're super happy, and it's like, no, it's not. And that's why also with the snow that you can make kind of self-shadowing, or some snow which, for example, in the shadow now of the cloud, and this snow is slightly darker than this snow which is now in the sunlight, and then you're getting this complexity. Because this is just shitloads of objects in the air, and they will react on the clouds, for example. They will react on the light which is in the scene. They will be also super visible where the light is, and they will be very much invisible where there's a dark sky in the middle of the night. Okay, so but it's still our atmospherics. Okay, cool. So we spoke about color correction. I guess now we can start. Before let me please finish the dry stuff, and then we'll just have fun. We'll look on the actual pictures. There's another one thing that I kind of like wanted to talk about. It's definitely not. Oh, it's this. Okay, let me say. Okay, that was this guy. Com department. Whoever was not on DQC, don't use